When we're dealing with parabolas, they come in two general types. The vertical type, which could face up or face down, and the horizontal type, which could face right or left. When we're dealing with the vertical type, its equation often appears in the form y minus k equals a times x minus h squared. It's important to note that in this form, h and k represent the coordinates of the vertex. It's also important to note that when you're dealing with the vertex, h and k appear with their respective x and y's, but with minus signs, which is generally interpreted to mean the sign switches. So if this said x minus 3, the coordinate would be positive 3. If this said y plus 4, the coordinate would be positive 4. An example of what a vertical parabola would look like is a vertex located anywhere. For the sake of argument here, I'll make it right about there. The vertex is always kind of sandwiched by the focus and the directrix. Depending on which way you want your parabola to face, the focus determines that. So if the focus is above the vertex, that means the parabola faces up. If the focus is below the vertex, that means the parabola faces down. So let's say, for instance, our focus was above. It's important also to note that when our focus is above or below, it's the distance between the focus and the vertex that matters. That distance should also be the same between the focus and the vertex and the directrix. So since in the example I'm just making up here, the distance appears to be 1, 2 units to get to the focus, so that means we'd have to go down 1, 2 units to get to our directrix. The directrix is always a line. We usually represent it with a dotted line here. And as we draw our curve, it's always important to check to make sure that that distance is indeed true. Now the same can be said of a horizontal parabola. In a horizontal parabola, we're using the same exact shape. It's essentially as if we rotated and got the exact same shape just facing sideways. The only difference in that rotation, and you might want to think back to kind of like the idea of inverses, is that the placement of the x and the y basically just switches. So instead of starting with y minus k in a horizontal, we start with x minus h. The a value remains the same, and we'll talk about that in a second. And since, again, we swapped, that means it's the y minus k in the parentheses being squared. Depending on which letter is being squared, you'll know if you're vertical or horizontal. Vertical parabolas have x squared, horizontal parabolas have y squared. Now, as I mentioned, that a value is consistent to both parabolas. When you're dealing with an a value, you're dealing with the part of the fraction, the part of the parabola that makes it fat or skinny. When you're dealing with any parabola, that a value always dictates the general shape. So again, when you're drawing yourself an example, say here with the vertex, the further away you draw the focus, the fatter or wider the parabola will be. If, for example, I draw this one relatively close by, let's say I'll put the focus here. Again, I'm just kind of making this up. I can do what I want, so to speak. But you'll notice I put the focus really close to the vertex. In this case, I put it only 1 unit away, which implies that the directrix must be 1 unit away in the opposite direction. The directrix then would be going vertically this time, since it's opposite. And as I wrap around, that'll generally give us the shape of our parabola. Now, that a value, the part that controls whether we're skinny or fat, that a value is based on a sort of general formula. That general formula comes from 1 over 4p, where p is the distance from the focus to the vertex. Now, you'll remember, of course, that that distance is also the same as the vertex to the directrix. So you could take it as either one or the other. Doesn't matter, it's the same distance. So in any example where you're going to see that a value, you will see it generally in fraction form, and you'll notice that it's usually a multiple of 4, because that'll mean that it was 4 times some distance to give you that number. An example of how this looks is provided on the right side here. And you'll notice in this example, we immediately jump out to the fact that y is in the parentheses squared, which implies that this is horizontal. When asked how we can tell, it's usually because of what's being squared. It's horizontal when y is the letter squared. Now, from this, we can also tell the vertex because the coordinates x, y are given to us. Now remember, when we have x with the number right there and y with the number right there, that implies those switch signs. So the order x comma y would give us -2, 3. If that means we plot our point at -2, 3, there's our starting value. Now the focus and the directrix depend upon what we call the a value, that fraction. That fraction came from that 1 over 4p formula I mentioned a moment ago. So since 1 over 4 times something gave us -1 over 8, that implies that that p-value must have been -2, because -2 times 4 is -8. Since that p-value is -2, and since we're dealing horizontally, that implies we would have gone 2 units to the left to get to our focus. That puts our coordinate of our focus at -4, 3, so we can fill that in. Now if we had to go 2 units to the left to get to our focus, that implies we'll have to go 2 units to the right to get to our directrix. Since it's horizontal, that means our directrix faces up and down, and since it passes through the x-axis at 0, our equation is x equals 0. As we sketch in our curve, the last thing we're asked to look at is the axis of symmetry. The axis of symmetry can be drawn in such a way to cut the parabola exactly in half. If I draw that line exactly halfway, we'll notice it goes through the y-axis at 3, so the equation of the axis of symmetry is y equals 3.